Hello everyone. Today I'm talking about the rule of thumb in reinforcement weight and ratio in different reinforced concrete structural elements. You know that reinforcement is the most expensive part in reinforced concrete elements. Concrete is not expensive and always easy to find and cheap, but reinforcement is expensive. And the ideal design or optimized design is to use the maximum capacity of reinforcement to take the loads that are mainly tension, shear, and sometimes compression, and at the same time use the least volume of reinforcement in the concrete. Always experienced design engineers and senior design engineers, when going to check the construction drawings, they are not going to check the applied loads first. First, they're going to check the reinforcement ratio in different structural elements, let's say beam, column, slab, foundation, or all these elements. And if it's in the range, they are generally accept the range. And if it's out, they're going to check the next step, why it is out of the range and how they can reduce this. Here are just general recommendations for the reinforcement ratio and weight of the reinforcement in concrete volume for different types of structural elements, but always remember you need to follow the minimum and maximum range for each element in the applied reinforcement ratio. And also one more point, in some cases you may have required reinforcement less than the minimum reinforcement ratio in the applied code. For, let's say, if you have very low load value, but anyway you have to provide the minimum reinforcement ratio even if you don't need that. But always remember you are not allowed to go above the range, because over reinforcement has just huge congestion problem, and it may have just some concrete pouring problem, and it might be just some construction issue and fail of the elements as well. So try always to stay on the range, and my recommendation is always try to be close to the minimum range to have optimized reinforcement concrete element design. So first step here is just bases. I've shown the bases here. It is just about 90 to 130 kilogram reinforcement per cubic concrete volume, and the percentage of reinforcement, if it is above, if it's between 1.2 to 1.7%, that is acceptable, but always try to keep in the minimum range. Second one is beam. You know that the beam is generally congested section beam, and if it is going about, let's say, about 600 beam, you definitely need some mid reinforcement as well, long reinforcement at the middle section. In that case it's going above, and in general we have about 250 to 350 kilogram reinforcement per cubic meter of concrete, and the range is 3.2 to 4.5% of the reinforcement of the concrete volume is reinforcement in section. And the third one is capping beam. Yeah, you know that the capping beam here I've shown. Capping beam is generally to connect the piles together and safe transfer of the loads above to the foundations. In this case, we have about 135 kilogram reinforcement, that is optimized range, and the reinforcement ratio about 1.7% of the section. If you achieve this one, it means that you have good design. Next one is column. That's the most important part. I say that columns, slabs, and shear walls are the most important parts in reinforced concrete design. And column is, in general, is about 1 to 4% of the section should be reinforcement. And myself, I always try to stay around 1%. That is the most efficient reinforcement design for column. And the range is about 200 to 450 kilogram per cubic meter of concrete. Just one very common issue in column design, sometimes you're going above the range, even if you're going around 4%, even less than 4%, my suggestion is that try to increase the concrete capacity or concrete strength. Let's say if you're using 40 MPa, try to use 50, 65, or 80 MPa to have reinforcement ratio in the range of 1% or maximum 2%. It is much cheaper to use less reinforcement rather than using higher strength concrete. You know that there are some problems in operation and curing of higher strength concrete, but anyway, after in big construction projects, if you saving millions of dollars, it's worth to save from reinforcement. The second here is ground beams. About, you see here, that's what we call it, ground beams, connecting elements, foundations together. It is about 230 to 330 kilogram per kilogram reinforcement per cubic volume of concrete, and that's about 2.9 to 4.2% of the section. And concrete footing, here it's just a single footing, and we're using about 70 to 100 kilogram per cubic meter, and that's about 0.9 to 4.2. You see that there's a big range, and for some items like this, that is single reinforcement, and let's say if it is just simple support and there's no there's no bending, we need just to have bottom reinforcement for compression and some top reinforcement for shrinkage. In that case here we may go just around 0.9%, but if it's complicated and you may have bigger loads and bigger section, definitely you will go around 4.2, but my suggestion is always try to stay around the lower ratio. And pile cap here, that is to connect some local points and stitch local pipes piled together. In this case here, the same is just we're using 110 to 150 kilogram reinforcement in concrete volume, 1 cubic meter of concrete volume, and the ratio is about 1.4 to 1.9%. And the last one in this page is plate slab. You see that plate slab is just uniform thickness slab spread around the floor, and just the columns are sitting on that one. In this case we're using 95 to 135 for weight of reinforcement in 1 cubic meter of concrete, and 1.2 to 1.7% is the ideal reinforcement. Here just you see that it is very, the maximum and minimum are very close, and but always try to stay in the lower range. I say that if you have about 1.5% here, that is ideal and very optimized. Next, we're going to raft foundation. It is just some type of base again, and we can say it is just base foundation or base, and same, we're using about 115 kilogram reinforcement, and 1.5% is the ideal and optimized reinforcement ratio. Retaining wall are the next. Your retaining wall, you mean that you know that here we will have long horizontal and vertical reinforcement always in both sides. Even if the load is not big, we definitely need for shrinkage and supporting the concrete. And in this case, we will have 110 to 115 reinforcement weight per cubic meter volume of concrete, and 1.4 to 1.9% of the volume in, let's say 1 cubic meter is the most optimized. Ribbed floor slab, or what we call it waffle slab, is just we're using about 80 to 120 kilogram reinforcement per volume of concrete, unit volume of concrete, and in this case if we go to 1 to 1.5%, that is optimized reinforcement design. For one-way slab, that is, you know that in one-way slab in general we have reinforcement in two ways. In short span we have the main bearing or load taking reinforcement, and in second direction we have reinforcement for shrinkage. Anyway, in this case we have about 75 to 125 reinforcement weight per unit volume of concrete, and 1 to 1.6% is ideal reinforcement ratio in the section. The second is two-way slab. It is almost same range, a little bit higher than one-way slab, and 67 to 135, and percentage is 0.9 to 1.7% of the section to be reinforcement. Concrete stair is the next. If you have about 130 to 170 kilogram reinforcement in unit volume of concrete is ideal, and the percentage is about 1.7 to 2.2. You see that for such a small section or for such a small structure, we have congestion of reinforcement. That's why it's going above 2.2, and we say it is just for mainly for the connections and the shape of the stairs that we need to cover to have continuity or just the integration between the reinforcement on top and bottom. Next one is tie beams. Here it is type of just floor beams, and in this case we have about 130 to 170 and 1.7 to 2.2%. And you see here that's the long reinforcement we have, and we have too many straps mainly in the middle to have any shear problem we have. That's generally a minimum. There's no big load in general, and if you just follow the minimum reinforcement in the code, it is good design. Second one, the last one in this page is transfer slab. You know, the transfer slab are just mainly we need a stronger slab to take the change in alignment of the columns, and we have in general shear problem, punching shear problem in top and bottom slab, and definitely we need thicker slab. But ideally if you go above around 150 kilogram reinforcement in 1 cubic meter concrete, and 1.9% is this is just a mid-range, and if you are around this range it should be okay. But anyway, it should be just something between one-way slab and two-way slab. Just remember, a transfer slab can be one-way slab or two-way slab, and in this case you need to follow those rules as well. Last page here is shear walls and gravity wall. For gravity walls, that is, I say that it is very rare in reinforced concrete design. We going to have just bigger reinforcement in shear wall in the walls, and it is very rare to have just expectation of having gravity load taking. In general, we have gravity plus lateral loading, but anyway, if it is used just for gravity loading, let's say 70 to 100 kilogram reinforcement per cubic meter volume of concrete is enough, and it is good design, and the ratio is 0.9 to 1.3%. And if it's going to be shear wall, that is taking lateral load and gravity load, this range is going to be 90 to 150 and 1.1 to 1.9%. You see here, it is just, we have in shear walls in general, we have two-way slab and two faces, and in general at the edges we have more reinforcement that is called core, and to have enough rigidity to connect to the other elements, top and bottom floors, and in this that's why the reinforcement ratio is going a little bit higher. And remember, we always have ties to have efficient shear transfer as well. And the last part I've left blank because there's no rule here for post-tension slab and post-tension beam, but remember, always we're using post-tensioning to reduce the volume of reinforcement. That is the whole idea. That's the main idea in post-tension design. And the main difference between post-tension and reinforced concrete is that in post-tensioning we're using bigger spans, less reinforcement for less reinforcement. I mean, the bigger spans and more economic spans with less reinforcement. But in this case, if you achieve definitely you're going to replace reinforcement with tendons, but if you're comparing the normal reinforced concrete as post-tension reinforced concrete, if you're going to have about 67% to 50% less reinforcement when you're replacing reinforcement with tension with the same slab capacity, with the same slab, it means that you have optimized post-tensioning reinforcement. It is just general rule of thumb. It is just general guides, but still you need to, sometimes you have very big loads, less loads, and limitations on the codes as well. For shrinkage, for other, for some cases, if you have just grade 1, 2, 3 corrosive soils or just aggressive soils, and in this case here you may have just some or aggressive conditions, and definitely in these cases you may have more reinforcement, and just depending on the other situations you may have more reinforcement. But these are just general rule of thumbs that is helpful to understand what's the optimized range, and you can understand with the first check if it is wrong, if it is okay, or if it is under the limit. Hopefully it is helpful for you to understand what's the design rule of thumb for reinforced concrete and what is the optimized range of reinforcement in concrete elements. Thanks for watching.